Hey everyone! Today we're diving into PDF, which stands for Probability Density Function. Unlike PMF, which works with discrete values like dice rolls, PDF is used when we have continuous random variables with infinite possible values. Think about measuring someone's height. It could be 170.1 centimeters, 170.12 centimeters, 170.123 centimeters, and so on forever. Because there are infinite possibilities, we can't calculate the probability of an exact value, so instead we calculate probability over ranges using a density function. Let me show you how this works end to end. We start with a continuous random variable where we can't measure the exact probability of a single point. Instead, we use a density function which creates a PDF curve. Think of the famous bell curve. The key insight is that the area under this curve between 2 points gives us the probability for that range. So if you want to know the probability that someone's height is between 165 and 175 centimeters, you'd calculate the area under the PDF curve between those two values. The most important PDF in machine learning is the normal or Gaussian distribution, that classic bell-shaped curve. It's defined by just two parameters, the mean, which tells you where the center peak is, and the standard deviation, which tells you how spread out the data is. For example, human heights typically follow a normal distribution with a mean around 170 centimeters and a standard deviation of about 10 centimeters. The beautiful thing is that the total area under the curve always equals 1, representing 100% probability. Let me show you a powerful real-world use case: anomaly detection for fraud. Imagine you model normal transaction amounts using a Gaussian PDF with a mean of $50 and standard deviation of $20. When a new transaction of $500 comes in, you calculate its probability density using the PDF formula, and you'll get an extremely low value. If that probability falls below your threshold, you flag it as an anomaly, potentially fraudulent. This same technique is used everywhere, from detecting network intrusions to monitoring server performance for unusual spikes. Alright, let's wrap this up. Remember the key difference: PMF is for discrete variables like dice rolls and gives you actual probabilities, while PDF is for continuous variables like height and gives you density values. With PDF, the probability of any exact value is technically zero, only ranges matter. The normal distribution is your go-to PDF in machine learning, showing up everywhere from Gaussian naive Bayes to anomaly detection. Understanding PMF and PDF is crucial because at their core, most ML algorithms are estimating probability distributions to make predictions. Now you've got the foundation to understand how these models really work under the hood.